Good evening, everybody. I am going to show a series of videos showing my solution to real-life interview problems given by companies. Um, a lot of companies today require you to solve a programming problem in order to get a job interview. I think it's a great idea. It kind of shows straight off the bat if you know how to program, or um, if you don't even get the interview straight from the beginning. It shows you. I did the solution for a couple of companies. I'm going to start with my solution to a company named Yodle. They require you to solve this problem in order to get a job interview, and then I'm going to show some other solutions to other problems. I think it's a nice way for people to, learn how to handle these problems, and a person get an insight at least of how I myself solve these problems. Okay, so let's get started with Yodle's problem. They give you a flat text file with a list of numbers, each separated by a space. The first line contains one single number. Each line below has one more number than the last. There's about 100 lines, but you don't know how many lines. It could be 100, it could be 1,000, it could be 1,000,000. What you have to do once given this file, these are the rules. Once you're given the file, you have to take the very first number in the top line, and you have to add it to one of the adjacent number below. So I'm giving 9235, which is the first number. Then I could go to the line below. I could either add this number 1996 or add the other number 637. That's the other adjacent number. So at the beginning I took this path. Then I could add the two adjacent number below 996, which is this guy or this guy. So I took this path, and so on and so forth. You could add any of these two adjacent number, any of these two adjacent number, and you pretty much add all the numbers until you get to the bottom. What you want to do is find the path whose sum of number is the largest. Now, just adding the biggest number of the two adjacent nodes is not a solution, trust me. You could have like a large number here, a very small number here, and then all the numbers in this branch be very small, and the numbers here be very large. So you have to actually take into consideration both sides, even if the number is smaller than one. So the rules is just add all these numbers until you find the path which has the largest sum. My first approach to solving this problem was to use recursion. Pretty much take the first number, add it to the number in the left by recursively calling the same function. Also add it to the number in the right by recursive calling the same function, and do this until you reach the bottom. Now, when you add the left branch and the right branch, you take the biggest sum you added. But since you're doing this recursively, you actually check every possible combination. So let's see, by the rule, I take the first number and then I go I add it by recursively calling the left node, right? Now I'm here and it's going to do the same thing. I add it by recursively calling the left node. I add it by recursively calling the left node. I add it by recursively calling the left node. Then when I reach to the end, the recursion goes up one level, and the next rule was after you recursively add it to the left node, now add it to the right node. So recursively, my algorithm is going to add all these branches up and return the sum. Then it's going to add all these branches up and return the sum. Then it's going to go, once it evaluates these two, it's going to go up one more node up, and then it's going to take the next path. So it's going to go then this path here, and then here it could choose here or here. So the rule is first left and right. So it's going to go down here. It's going to add all these numbers up. Then it's going to go to the right, and it's going to add all these numbers up. And little by little, it's going to just go through the all possible combinations, giving me the sum of each one. And I gotta remember which path. I don't even have to remember. All we need is the highest number. Then I just got to remember which was the highest sum, and give the result of the highest sum. Now recursion is a very nice, elegant solution. A very small piece of code, very simple rules, and it does everything. The only problem with this solution is this: it's not very efficient. You have to go through each path, and sometimes you got to repeat the path. If you see, let's see, a place like, if I take this path here and then go to 335, I have to evaluate these two nodes, right? Let's say I would have gone through a different path. I would have gone here, here, then here. Then I have to choose right or left. Then again, I end up here, and then again, I have to evaluate this node. So a lot of nodes at the bottom get repeated quite a bit. So you keep on kind of recursing through certain branches over and over and over again in order to calculate your solution. This is very inefficient. So the next step to improving this algorithm is using something called dynamic programming. Dynamic programming, what it does is it uses the same recursion algorithm, but what it does is once it goes through an entire branch, it remembers what the optimal solution for that branch is, and the next time the algorithm returns to that branch, instead of evaluating everything, it just remembers what the answer was, because you store the answer in an array, and it just takes the answer without having to repeating everything. So this is how it works. Let's say my recursion algorithm is going from here to here to here, right? Here. Then this guy, node 32, this node with value 3269, has to go through all these possible combinations here in pink, in purple, whatever, to find what the optimal solution is. Now let's say I go later on through this path. I go here, 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 and then I go here. Then again, once I'm here, I have to repeat everything again. So what I do is I remember what the optimal solution is at each node. So when I go here, 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 and I evaluate all this value, and I find out that for this small triangle, the biggest sum I could get is 17,484. That is the biggest sum I could get taking all the different paths. Now once I go through the recursion algorithm and I take a different path, I go from here to here, back to 3269. Now I don't have to evaluate everything down here, because I remember in an array that the biggest sum of this node 3265 plus all this path was 1748. So all I have to do, instead of going 1, 2, 3, then 4, 5, then 6, 7, 8, instead of going all those steps, I just go 1, 2, 3, that's it. Now I could go back and evaluate this branch. So I save a lot of recursion. Now this seems like I save maybe like 5 or 6 steps, but remember this is hundreds of lines long, so I actually save quite a bit of recursion, and I increase the algorithm quite a bit. Okay, so dynamic programming helps. I store data in an array of what the optimal solution is for little sub triangles. So when my recursive algorithm goes to that node again, I don't have to repeat all the sub nodes. I just take the value I stored in the array telling me what the optimal solution was. If you notice something, dynamic programming pretty much breaks everything into small triangles. If you go through each path and go through the almost the very final line, the line right before the final line, the sub triangles is basically this number on top plus these two numbers on the bottom. The optimal path of this, since there's only one number at the bottom, is simply the biggest number of both of them. So once I'm at this node at 3399, to find what is the best path, which will give me the biggest number between the left and the right number, all I have to do is just add the biggest number below to 3395, which gives me 1147. This is great in that I could pretty much eliminate the entire bottom line by just doing this, just by taking 3395 and adding it to the biggest number of these two guys, then going to 3350 and adding it to the biggest number of these two guys, and doing it so on and so on. So the optimal solution for this mini triangle is 3395 plus 8032, which gives me 11431. The optimal path for 3350 is taking 3350 plus the biggest number, which is 9427, which gives me 1271. So taking advantage of that, I could pretty much just take the number right before the last line and add it to the biggest number below, and just keep on doing this for every single line. Then I take 3350, add it to the biggest number of these two, take 4788, add it to the biggest number of these two, which is 9427, take 7546, add it to the biggest number of these two. So once I do this, I have an array of optimal paths, which is 11, 4, 31, 12, 7, 7, 14, 25, 10, 52, and I've completely deleted a whole line from my array. But the nice thing is, I could repeat the same thing again. I could go to this number, and this number plus the optimal path of these two now is simply, since I've already deleted the line below, is simply 972 plus the sum of the biggest of these two numbers. So 972 plus 1277 is 750, I believe that. So 13150. This font is a little weird. I'm pretty sure 13750. And I do the same for this for the next two lines. So all I have to do, now that I eliminated this bottom line, all I have to do for this line is just take this, whatever number's here, and add it to the biggest number of the two adjacent, and so on and so forth. So now I've taken this line, and I've got, these are the optimal paths for those numbers, and I wiped out this entire line. And I could keep on doing the same thing over and over again. So now I take this number, which is 96, and add it to whatever the biggest number is of the two numbers below, because there's only one number below. I don't have to go through the entire tree since it's already been optimized. And I get these two numbers, 26607, 21891, and then for the top line, I just do the same thing. What did I find out about this? I don't even have to use recursion. I just take my huge array, which is again a lot bigger than this. I start at the one line before the final line, and just go through each element and just add to it whatever the biggest number is below it, and then keep on doing this. And in one path, I will go from the bottom to the top and get my optimal path, my optimal solution. One pass, no recursion, nothing. That's the most optimized method that I could come up with. I've been doing a lot of JavaScript code since I was a lady asked me to write a game for her website, and that was the freshest thing on my mind. But I'll put up the code in C, Pascal, a compiler I wrote in Spanish called Logica, so that you could see how the language works in all these different other languages, PHP, whatever. But I did it I did it in JavaScript because at the moment that was the freshest thing in my mind. I was just pretty sharp at it. So I wrote a function that takes the text file. I load the text file, which was called triangle.txt, into an array called data. The array is split by having a new line. I have another array called sum, which is going to be the result of me summing, the one node plus the biggest of the two nodes below, like I said in the algorithm. Right now it's empty because it has nothing. And pretty much this is my loop here. My loop is I start at the not at the very last line, but at one line before the very last line. Now, since my array starts at 0, um, I originally had to say -1, but because I'm going one line above, I have to say -2. That's because my array starts from index equals 0 instead of 1. And then I go up one line, one by one, and I just do what I said I was going to do, which is pretty much just, just sum the max number of the two nodes below. So very simple routine. It looks at a certain node. It takes that node and it adds it by the maximum of the left or right child node below it. So in one path, I just go through everything, and boom, I found my optimal solution. No recursion, no having to transfer to the entire tree. Really, I just go backwards and just add the biggest of the left or the right node to the node above it, and I get my solution. Now I'm going to show you what the data file is. This is what the actual data file looks like. It's there's one number above it, but it's getting cut off because of the region I chose to record on the screen. But it's actually about 100 lines long, and it's a lot of data. And I have to pretty much execute the code and get my final solution. So this is my file. It's called yoddle.html, and let me run it. Boom, super fast. I even blinked. It just didn't even pause. And it says the sum of the maximum number is 752506. Let me show you the source code. This is the source code. This is actually the code that I implemented, which is running the code. Now I send an email to Yodle, and they verified that the solution was correct. I think this is as optimal as you can get. I don't think it could get any more optimal than that. I know that if I would have used recursion, they would have been happy. If I used dynamic programming, they would have been very happy because it's an improvement of recursion. This solution is not something that actually they teach you in school. It's something that a programmer using their own brain and their own logic would come up with. So I'm very happy with this solution, since I took what they teach you, which is recursion, and now what they're teaching you, which is dynamic programming, and I went one step further and I did my own optimization by noticing that, hey, the sub dynamic programming division actually lends itself for me to come up with a new algorithm where I don't even have to do recursion at all. I just kind of add everything up and keep on remembering the sum of the last line. So that's it. I hope everybody understood what the solution to my problem was. I'm going to show you my solutions to other problems, which are very different from this one, from other companies. This was Yodle's. This was my solution to a company named Yodle here in New York City. The programming project for in order for you to get a response from them to set up an interview. Thank you guys, and goodbye.